If you like the content of this video, please do press the like button and subscribe. Limit is a mathematical concept based on the idea of closeness. It is used primarily to assign values to functions at points where no values are defined in such a way as to be consistent with nearby values. The idea of a limit is the basis of all calculus. In the example, the function value does not exist at x equals 1, but we can use a simple factorizing trick to get rid of x minus 1 from the denominator. Formally, if you pick a number epsilon, if the limit L exists, then it must be possible to find a number delta, as depicted in the graph. The laws of limit are pretty obvious, and the proofs are trivial. Let's consider an example. We apply the standard trick of multiplying both numerator and denominator by the conjugate radical expression to remove the denominator terms that were becoming zero. We now evaluate an important limit that is useful. The proof is easy to establish by simply considering the relationship between the area of the inner triangle, OAP, area of the arc, OAP, and the area of the outer triangle, OAT. Sometimes only one-sided limits may exist, as shown in this example. One-sided limits lead us to the definitions of right continuous and left continuous functions. Sometimes, you see a limit is stated as infinity. This does not mean that the limit exists, as there is no real number, such as infinity. It is simply a concise way of saying that the limit does not exist. For a continuous function, if f of a equals f of b, then Rolle's theorem states that there must be a point c between a and b where the derivative is 0. The mean value theorem states that for a continuous function, there must be a point c between a and b where the derivative, that is the slope, is the same as the slope from point a to point b. Both these theorems are pretty intuitive when we look at the graphs. Now that we have an understanding of limits, we move on to the topic of derivatives in the next session.